Hello, everybody. My name is Rafael. I work as a head of logistics of Metro de Madrid. In this presentation, we will briefly explain the two pilot projects carried out of Metro de Madrid in relation to the urban distribution of e-commerce parcels. The pilot project sought to analyze the viability of the operation models and the useful for the logistic operation that participated in it. Both pilot projects were carried with a real logistic operation company with real parcels and real customer, and I hope you find it interesting. So let's get started. The problem that there are when the main problem we face in a city like Madrid, and I think it's similar in other major European cities, is that the urban freight distribution already accounts for a very high percentage of the city total traffic. In Madrid, it is close to 40% and is expected to reach near the half, the 50% this year. And there are several reasons for this. The first one, and everything is known, is the growth of e-commerce. And in our case, it cannot be absorbed by simply increasing the number of vans. In Madrid, also, as in other European capitals, there are a low emission zone, which means that many of the current vehicles will no longer be allowed to enter in these restricted areas. And the last one is the urban distribution adapted today needs, or we think needs a new model. So this the key factor make that clear that we need different solution. In our case, to give you a sense of scale, around 800,000 parcels from e-commerce are delivered daily in the Madrid region. Our proposal, our objective is using the metro as an operator for urban freight distribution, but we know or we assume that it's a complementary solution. We never think and we never consider it as a silver bullet to sort out the problem, the whole problem. However, if we can absorb even 4% of those parcels, we could remove around 350 vans, from the street every day. That means that we're reducing traffic by more or less 30,000 kilometers per day on the Madrid road. And what is most important for us is a saving of 5 million euros per year in externalities, in both in social and in environmental. So, what are the main guiding principles that support the project? The first is a very big red line for us is no interfering with the Metro de Madrid current passenger service. In other words, this solution is complementary and in no way alter the existing service, neither in terms of frequency nor in ability of our passengers. For us, it's a red line. The second principle is the capacity to reuse the existing infrastructure, train and station, with the goal of maximizing their use and leverage this backbone network to become an option for the urban freight distribution. And finally, for us, it must be a non-exclusive public service. That means that it should be able to serve different types of operator, logistic provider, or retail companies. So let's move on. The first pilot we carried out in Metro de Madrid at the end of 2024, in September and October and mid of November. This pilot took place on line 12. Line 12 in Madrid is a circular line that runs through the southern region of Madrid, as you can see here in the picture. And this model was developed in collaboration with the company GLS, involved collecting all the parcels from agencies located near the metro station in the south. And starting in the afternoon, we inserted a freight train, a cargo train, between two passengers service train, but never mixed them in order to avoid any kind of interference. This train stopped at selected station to collect parcel handed over by several GLA's agencies. The parcels were consolidated and the train then transported to the maintenance depot. We can here see in more detail. So let me see. The train will start its route along the line and stop at the specific station where the ELS agencies will deliver the parcels at a specific and fixed time. The train continues along the line, stopping at each station to collect the parcels, and finally arrive at the maintenance depot. There in the depot, the parcels were transferred to a truck, to a GLS truck, and the goal here is to consolidate all the shipment that collected by the agency and avoid multiple trips from each one. Then, with all the parcels consolidated in the truck went to the micro fulfillment center of GLAs in the office key of Madrid. The next chart, I think, is really interesting because it shows the train schedule. In other words, it's the graphical representation of train movement over time. Here, the green lines represent the frequency and path of the passenger train service. And we did, as you can see in the blue and the orange lines, was to insert a cargo train between two passenger trains in a way that wouldn't affect the passenger service. How did we do this? For much of the route, the cargo train didn't stop at 13 stations or stop at 13 stations, which allow us to closely follow to the passenger train ahead. When the train stopped in certain station, we took much time, but then continuing the journey without a stop and getting back behind the train ahead, since there were long stretches where the cargo train didn't need to stop. In this picture, you can see several photos of one of the stations involved in the pilot, Hospital Severo Ochoa station, and there are, for us, for our point of view, a key few aspects that are here important from a logistic point of view. No? First, the station has elevator. In fact, 80% of the Metro Madrid station has elevator. That we think is an important and significant advantage to do any logistic operation. Then there are the access and the circulation areas. The ticketing area must have enough space to allow the movement of goods. And finally, the platform will be wide, an area where the transfer of goods from the station and the train take place. Here is in this slide you can see a depot, a maintaining depot. On every metro in Madrid line, there is a maintaining depot located either at the beginning or the end of the line. No? These facilities are used for maintenance activity and also serve as a train garage. And this is where the cargo train begins its route to collect all the parcels delivered by the agencies, the GLS agencies. And an hour later, after completing the route, the train returns to the depot where the parcels are transferred to a truck for delivered to the logistics center from GLS. About the rolling stock we use, here you can see an example of one of our train. It's on a specific series and using by Metro de Madrid. We use both the train and the rolling cages, which had a dimension similar to a Euro pallet and about 1.8 meter in height, with a load capacity of 500 kilo. And depending on the type of parcels, each rolling cage could have between 80 or 100 parcels. So you can hear the possible arrangement or layout of these cages inside the train. And it's important to note that the capacity that we used during the pilot was much lower than our real capacity, because we use only one or two coaches of our train, but we can use 6 available cars. So in one train composed by 6 cars, the capacity could be reached around 7,000 parcels per trip. So let's move to the next pilot. This one is completely different from the one I described before. It was also carried out at the end of 2024, but the goal here was to inject parcels directly into the city center, specifically into the Madrid low emission zones. Here, how the flow works. We receive the parcel from the retailer, whose distribution center is located in Toledo, near Madrid. The goods arrived by an electric truck and were delivered to a train in the maintenance depot, like the one I showed you before. In this case, the depot was located in Villaverde, near Getafe, in the south of Madrid also. And from there, we injected a train into the metro line, which traveled to 2 specific stations. This station act or has the role as a micro hub, as a micro warehouses. And the final step here was to carry out in-home deliveries to customers from those stations. Here the detail. As I mentioned, the electric truck arrives at 5 in the morning. The train runs along the line and stops at the station where we set up the micro hub, in this case, Embajadores and Plaza de España. And once the parcels are unloaded from the train into the micro hub, which is located inside the station, the last mile delivery are made in a proper hour when customers are available to receive them, from 9:30 in Madrid. And these deliveries within the low emission zone were carried out either on foot by couriers or using cargo bikes. If we zoom in, we have the detail of the map of Madrid low emission zone and the area where we are able to cover with metro urban cargo distribution system. No? The area marked in red represent the covered zones in the pilot, which we serve from the micro hub using cargo bikes and workers. Here you have an example of a micro hub. You have the layout and the dimension of, and we have two stations, sorry, here in Embajadores and in Plaza de España. And this station as a micro hub to deliver to the final customer. So, similar to what we saw earlier, this is the layout of the train. The key difference here, and it's important to highlight because reverse logistics for us is very different between one model and another. In this case, we use last mile delivery bags, sacks, for reference, and these were loaded into the train in bulk, secure with a specific mesh restraint. And for us, this allowed to use in a more versatile container format. No? As you can see here, the layout zone is an approximate, is an approach, but it's worth noting that the pilot use is only a very small percentage of the train total capacity. And that's all for my part. I have a video, but I think I don't have enough time, so it's everything for my part. Thank you very much.
Thank you.